works.
Does it have to do anything with proofs, this lesson?
Yes. Everything will have to do with proofs moving forward.
Oh, great. Woohoo. I love proofs.
Are we being sarcastic? Oh, okay. You haven't even seen anything yet. Okay. A point or segment, line or ray that divides a segment into two congruent segments bisects the segment. The bisection point is called the midpoint of the segment. Only segments have midpoints. Okay, let's talk about this. The prefix bi means two. A bicycle has two wheels. A bisector will split it into two. So if you're going to bisect a segment, you're taking a segment and you're going to create two congruent segments. I'm going to say it again. If you bisect a segment, you will take a segment and it will create two congruent segments. Now, think about this. When you bisect a segment, one segment is doing the bisecting, the other one is receiving the bisecting. So if I were to take an apple and I want to bisect this apple, I want to split it into two equal parts. It'll be difficult, but let's say I can do it. I'm going to take the knife and I'm going to chop that apple and it's going to fall into two. Do we agree? Now, the knife, is it the bisector? Is it doing the bisecting or is it receiving the bisecting? It's the bisector. It's doing the bisecting, right? Since it's doing the bisecting, does the knife also fall into two parts or does it stay? Good. What's the only thing that falls into two parts? The part that is cut or receiving the bisecting. So here, given XY bisects AC at B, you tell me which part of this statement is doing the bisecting and which part is receiving the bisecting. Sam.
Is YBX considered the bisecting?
Say it one more time.
YBX.
YBX. Okay, how do we name a segment with how many points? YX, exactly. YX is doing the bisecting, and what's receiving the bisecting? AC. So that means that we can conclude that segment AB is congruent to segment BC. I cannot say that segment XB or segment BY are congruent. I cannot say that because that wasn't bisected. Only AC was bisected. All right, for number 2, I'm also only want one conclusion. So if D is the midpoint of segment FE, Julia? So remember, how do we name segments? Not with just one letter. Good. Segment FD and it's congruent to segment. Excellent. So remember, a lot of these words pretty much tell you the meaning just by knowing. So like midpoint, doesn't that sound like middle? Middle point. It's the point that's in the middle. Equal segments on either side. Now, these are all definitions. What's really nice about definitions is that in proofs, we don't have to memorize the full definition. In proofs, we're allowed to say definition of and then just write the word down. So that's the best part of dealing with definitions versus theorems. For theorems, we have to memorize it all. All right, number 3, I'm only going to come to 2 conclusions. I only want 2 conclusions. So the given information is telling us that segment OK is congruent to segment KP. If segment OK is congruent to segment KP, there's 2 different conclusions we can come to. Jerry? Bisects. Excellent. So we can say line JM bisects segment OP. Beautiful. So here JM is the knife. JM is the knife, OP is getting chopped.
K is the midpoint of OP.
Excellent. The next conclusion is K is the midpoint of segment OP. All right, so we knew the prefix bi meant two. So if we bisected a segment, we got two equal segments, two congruent segments. What does the prefix tri mean? The prefix tri, Livy. 3. Prefix tri means 3. Triangles have 3 sides. Tricycles have 3 wheels. If we're going to trisect a segment, we're going to split it into 3 congruent segments. 3 congruent segments. So 2 points are segments, rays are lines that divide a segment into 3 congruent segments, trisect the segment. The 2 points at which the segment is divided are called the trisection points of the segment. Only segments have trisection points. All right, so here we are given segment AR is congruent to segment RS, which is congruent to segment SC. All right, do we agree based on how we mark things that a segment has been split into 3 equal segments?
Yeah.
All right, what was the total segment initially before it was split into 3 equal parts? What is the total segment? Excellent. Our total segment was segment AC. So the points that are in the middle, those are the ones that do the trisecting. So point R and point S, those were the ones that split the segments because A and C are the endpoints of the segment. So it's always the points in the middle that split it. So there's only one conclusion here. It's going to be that R and S trisect segment AC. Okay, are we ready for the next one? There's only one conclusion I want here. Sorry, Michael, you want to tell me? Is that what your hand was up? Excellent. So here it says E and F are trisection points of segment DG. Here's our segment, and what's happened? We are trisecting it. When you trisect a segment, you make it into 3 congruent segments. So like Michael said, segment DE will be congruent to segment EF, which is congruent to segment FG. So segment DE congruent to segment EF, congruent to segment FG. Okay, so just to recap real quick. When you bisected a segment, what did we get? When we bisected a segment, we get 2 what? Congruent what? Segments. When you bisect a segment, you get 2 congruent segments. When you trisect a segment, what do you get? 3 congruent segments. So now we're going to apply those same words to angles. So when you bisect an angle, you're not going to get 2 segments that are congruent. Guess what you're going to get? 2 angles that are congruent. So when you bisect a segment, you get segments. When you bisect an angle, you get angles. So a ray that divides an angle into 2 congruent angles bisects the angle. The dividing ray is called the bisector of the angle. All right, so here our given information is angle ABD, mark it with a loop, is congruent to angle DBC. Make sure you stagger your marking so they're not connected. All right, do you all see the big angle here, ABC? Do we agree that big angle ABC has now been split? It has been split into two equal angles, two congruent angles. What part of this diagram is physically splitting the angle into two? Maya? Excellent, ray BD. So what we're going to write is ray BD bisects, and I shortcut bisects as BIS, angle ABC. That's our conclusion. All right, let's talk about angle trisectors. Let's talk about angle trisectors. So when you trisect a segment, don't we get three segments, congruent segments? What do you think is going to happen when we trisect an angle? Three congruent angles. We'll get three congruent angles. So two rays that divide an angle into three congruent angles trisect the angle. The two dividing rays are called trisectors, exactly. So given ray SV and ray SX are trisectors of angle TSY. First thing I want to point out here, do you notice in the given information I called it a ray SV and I called it a ray SX? But in the diagram, what are they drawn as? They're drawn as segments. I want to tell you that's absolutely okay, and you're going to see that a lot in the textbook, where things are given as lines or rays, but they're drawn as segments. The reason that is okay is because in every line or every ray, aren't there segments in there? So anything can be drawn as a segment and just know in our heads if it's given as a line or if it's given as a ray, it extends, which means like SV goes on forever past V and SX goes on forever past X. It doesn't need to be drawn if it's given to us. In this problem, it makes no difference on our lives at all. I just want to let you know that that's okay. All right, so what are we trisecting? We are trisecting angle TSY. What you need to do is look at the angle and identify the vertex. Which is the vertex in angle TSY? Julia? S. You're going to look inside the vertex. So here's S, look inside. Inside the vertex, do you see three angles? Yes, I'm going to number them 1, 2, and 3. Those are going to be the three angles that are congruent by the definition of a trisector. So angle 1 is congruent to angle